Example 3. Find the equation of the tangent line to f of x equals cosine x e to the x at x equals 0. So we know that in order to find the equation of the tangent line, we need to know the point where the tangent line touches, and we need to know what the derivative is at the point we're interested in, because that will give us the slope. So f of 0 means I'm going to take 0 and I'm going to plug it into my function. So cosine of 0 times e to the 0. Cosine of 0 is 1, and e to the 0 is also 1. So 1 times 1 is 1, which means my point is going to be 0, 1. The point where the tangent line touches this function is at the point 0, 1. In order to get my derivative at 0, I'm going to have to use a product rule to find the first derivative of this function. Now here's a case, like I mentioned before, where we're calling this function f of x. So when we do our side work, it might be confusing to call our functions f of x and g of x. So instead I'm just going to call them f and g to remember that I'm just doing this on the side. So my f is cosine x and my g is e to the x. The derivative of cosine is negative sine, and the derivative of e to the x is e to the x. So now I'm going to do f prime times g. So over here I have negative sine x times e to the x plus f times g prime. So cosine x times e to the x. So if I want to know the derivative at 0, negative sine of 0 times e to the 0 plus cosine of 0 times e to the 0. Now sine of 0 is 0, so 0 times 1 is 0. And then cosine of 0 is 1, and e to the 0 is 1. So I have 0 plus 1 equals 1. So the slope of my line is 1. So that gives me y equals x plus b. Now I can plug in my point to solve for b. And my point again was 0, 1. So y is going to equal 1 when x equals 0. So that tells me that b has to equal 1. So finally, the equation of my line is y equals x plus 1. So I was able to find the equation of the tangent line that touches the function cosine x e to the x at x equals 0. Again, the process is the same as we've done before for tangent lines, only now the derivative is a little more complex. For the next problem, we're going to be looking at both first and second derivatives. Let's give it a try. Example 4. Find the first and second derivative of f of x equals ln x times x to the 5th. So like before, if we want to find the second derivative of a function, we need to apply the rules that we know about derivatives to the first derivative of the function. So in this case, we'll start with the first derivative and then use that to find the second derivative. So our first derivative here, we're going to find by using the product rule. We have two things multiplied together. So I'm going to call the first function f and the second function g. From there, I'm going to find each of their respective derivatives. So the derivative of the natural log of x is 1 over x, and the derivative of x to the 5th is 5x to the 4th. Now, applying my product rule, I'm going to have f prime times g. So I have 1 over x times x to the 5th plus f times g prime. So the natural log of x times 5x to the 4th. I want you to notice that I can simplify my first term a little bit. So if I have 1 over x times x to the 5th, the x on the bottom will cancel one of the x's on the top, and I can simplify that to x to the 4th. So I'm going to do that before I go to my second derivative. The second term, I'm going to leave it as is. There's not too much to simplify there. So now I have my first derivative. And now from here, I want to find the second derivative. Now the first term is x to the 4th. So to get the second derivative, I can just take the derivative of that first term, no problem. Power comes down, subtract 1 from the power. However, the second term, I notice, is two things multiplied together. So I have to do another product rule in order to get the result of the derivative of this second part. So again, I'm going to pick my first function to be f and my second function to be g. Then I'm going to find each of their respective derivatives. So the derivative of ln x is 1 over x, and the derivative of 5x to the fourth is 20x cubed. So now I'm going to do f prime times g. So 1 over x times 5x to the fourth plus f times g prime. So plus the natural log of x times g prime, which is 20x cubed. And again, I'm going to simplify that middle term. So here, 4x cubed stays the same. Now, the x here from the 1 over x will cancel one of the x's from this x to the fourth. So that's going to leave me with 5x cubed. So my last term here, I don't need to simplify anything. So I have the natural log of x times 20x cubed. And that is my second derivative. So again, I was able to find my first derivative using the product rule, and then I was able to get to my second derivative using the product rule again for that second term. Let's try another example.